Okay, the first thing we need to discuss is what's called the rule of i's. Okay, kind of goes along with that I equals the square root of -1 and the I squared equals -1. So there's a rule of i's here that we want to talk about. I'm going to put it up in the corner of your notes here. All right, the rule of i's. So, the rule of i's is actually really easy to remember. Anybody in here have any younger siblings? Lots of people. All right, I myself was the youngest. And when the youngest tends to finally beat you at something, not yet, hasn't happened yet. Well, someday it will. Someday it will. Okay. What do they say? Anybody have? What do they do? They're just like, oh, cool, I beat you. Is that what they say?
You brag about it.
It's not what I said. I bragged about it. Heck yeah, I did. All right. It was, I won. Right? Yeah. I won. Well, I won, negatives in the middle. Huh? Yeah. I won, negatives in the middle. That is the rule of i's. I won, negatives in the middle. What that tells us then is the pattern. That says that we have I squared, I cubed, and I to the fourth. That pattern then repeats for I to the fifth, I to the sixth, I to the seventh, I to the eighth. Repeats for I to the ninth, I to the 10th, I to the 11th, I to the 12th, so on and so forth. Okay? The rule of i's is I won, negatives in the middle. Okay? So, why? Well, if you take a look at I cubed is simply I squared times I, right? What's I cubed? I squared times I? Yeah, well, what's I squared? I squared is -1. And so we've got -1 times I, which is -I. I to the fourth is I squared times I squared. Well, I squared is -1, so that's -1 times -1, which is +1. All right? Questions? Again, think of younger siblings. I won. Negatives in the middle. Okay? So there's our rule of i's. That shows up every once in a while. Okay? Obviously, you're going to see an I squared often. Okay? But every once in a while, you run into an I cubed or an I to the fourth. Okay? And so it's handy to know the pattern so you can go right to the answer as opposed to having to break it down all the time. Okay? Okay. So there we go. There's the rule of i's. Let's go ahead then and take a look at what we're doing today new, which is we are multiplying complex numbers. So, multiplying complex numbers. The nice thing about this is really we've done the pattern before. There's a pattern to do this, how we do this all the time. And it's the same as multiplying binomials. Okay, because complex numbers look like binomials. If you look right here, that looks like I'm multiplying two binomials. But these are not called binomials. They're called complex numbers. Because I is not a variable. I is the imaginary unit. I is an imaginary number. So this isn't a binomial. Binomials are like x plus 2. Okay, x being a variable. So this is complex numbers, but we treat them the same. How do you multiply binomials? We've done that before. How do we do it? FOIL, exactly. First, outside, inside, last, right? Well, that is the exact same way we multiply complex numbers. So let's just dive right into an example. Let's take a look at number 8. Okay, so taking a look at number 8, we're going to FOIL. So we take our first term times our first term. Outside terms is going to be that first term times this last term here. Inside terms, and then last terms. So you take 4 times -5, 4 times 4i, -3i times -5, and -3i times 4i. All right, so we now have -20 plus 16i plus 15i minus 12i squared. But what's I squared? Negative 1. That's negative 1, so I'm going to rewrite here. We got negative 20 plus 16i plus 15i plus 12. And now we combine like terms like we did yesterday. Combine the real parts and combine the imaginary parts. So what's negative 20 plus 12? Negative 8. And 16i plus 15i. Questions? Yeah, that's it. That's all we're doing. Question, Caitlin? Okay. That's all we're doing. Okay, let's try another one. Number 9. Number 9. So, how are we going to multiply this? First, which is going to be what times what? 2 times negative 3. Then what? 2 times 6i. Then what? Negative I times negative 3. And negative I times 6i. All right. So we get negative 6 plus 12i plus 3i minus 6i squared. But I squared is negative 1. So that means we have negative 6 times negative 1, or positive 6. So negative 6 plus 12i plus 3i plus 6. When we combine the 6's, what do we get?
0.
We get 0. Those cancel each other out. Do we have to write the 0 down? No. So 12i plus 3i is 15i. And by the way, is that considered a complex number or a pure imaginary number? Pure imaginary number, because there is no real portion to it. It's 0 plus 15i. And obviously we don't have to write the 0 plus part. So we have 15i as our solution. Questions? Feeling pretty good? We'll get there. All right, so I want you guys to do one on your own. Let's take a look at number 11. For number 11, we have negative 1 plus 3i quantity squared. Okay, so, right, think x squared means x times x. So negative 1 plus 3i quantity squared means negative 1 plus 3i times negative 1 plus 3i. Make sure to write it that way. And go. Working on your own. When you guys are foiling this, we should be getting 1 minus 3i minus 3i plus 9i squared. But I squared is negative 1. So that means that's going to be a negative 9. So 1 minus 9 is negative 8. Negative 3i minus 3i is negative 6i. Questions? Yes, ma'am. It does matter. Complex numbers always have the real part first, then the imaginary part. Okay? Yep. We have to make sure we write it that way. Real number first, then the imaginary part. Okay, any other questions on 11? Let's take a look at 12. For number 12, do we have to FOIL here? No, we just have to distribute. Exactly. So we distribute 3i. It's going to give us 6i plus 6i squared. Well, again, I squared is negative 1, so that means we have 6 times negative 1. So we have 6i minus 6. Can we leave it that way? I just answered that question. No, we can't. Be careful when you do that, though. Okay? Be careful when you do that. Subtraction is not commutative. There's a commutative property for addition and a commutative property for multiplication, not one for subtraction. Meaning, 5 minus 2 and 2 minus 5 is not the same thing. So when you switch this into the proper order, make sure the negative comes along with the 6. It's negative 6 plus 6i. You've got to make sure you're writing it correctly, okay?
So you kind of treat the subtraction sign as a negative sign?
Right. That's exactly what you do. Yep. All right. Questions on 12? All right. Let's take a look now at number 10. Let's take a look at number 10. Number 10, again, we're not distributing. We don't have complex numbers. We have pure imaginary numbers. Okay? And so then multiplying these three imaginary numbers is going to be basically the same idea as multiplying three real numbers. Okay? You just take two of them, let's say the first two, and you multiply them together. So what is negative 2i times 5i? Negative 10i squared. Negative 10i squared. Let's hold off on the reducing it for right now, okay? Let's hold off on the reducing it for right now. All right, times negative I. Okay, so we have negative 10i squared times negative I. So now I want to multiply those together. Well, a negative times a negative is positive. And so we now have 10, what? I to the what? I cubed. I to the third power. I squared times I is I cubed. Okay? But think back to your rule of i's. Okay? Your rule of i's are sitting right up here. If we have I cubed, it's what? Negative I. So I cubed is actually negative I, which means our answer is negative 10i. Okay? Now, that answer is the exact same thing you would have gotten, because some of you wanted to reduce it when we were back up at this step. Right? Well, if you did that, you know that I squared is negative 1, so you have negative 10 times negative 1 times negative I. Well, negative 10 times negative 1 is 10 times negative I, which is exactly what we did here. We took 10 times negative I. Negative 10i. Okay, so we got to make sure that we can get to the right answer. We got to make sure we understand the steps we're taking. Okay, and you'll do just fine. Question.
But why is it if it's I squared and you reduce it or whatever, you take the I away, but not for this one?
Great question. Because of where I cubed, that rule for I cubed, where that comes from. Okay. And we talked about that briefly right back up here, where I cubed is I squared times I, right? And I squared is negative 1. And so that means I squared times I is negative 1 times I, which is then negative I. Okay? Same question? Yeah. Okay. Any other questions on number 10 or on the rule of i's? No? Then we've got one more. We want to do number 13. So taking a look at number 13, what's the first thing we're going to need to do? We've got to reduce our radicals, okay? So I see a couple of square roots that have negatives inside. So what do we do then? Pull an I out. Step 1, pull an I out. So we have I square root of 4. And again, the square root of negative 9, we have I square root of 9. You pull an I out. Okay? Well, what is the square root of 4? 2. So that means we have 2 plus 2i times negative 1 plus, and what's the square root of 9? 3. So we have 3i. And now it's a matter of multiplying like we've been doing. So we're going to take 2 times negative 1, 2 times 3i, 2i times negative 1, and 2i times 3i. So negative 2 plus 6i minus 2i plus 6i squared. Well, what's I squared? Negative 1. And we combine our like terms. So negative 8 plus 4i. Any questions? No? Okay, let's talk about homework.